Let's start with the definition of an algorithm. So simply we can say algorithm is nothing but it is a set of instructions to solve a particular problem. So we can give a step-by-step solution for solving a particular problem. In general words, we can say that is a uh, algorithm. So now we can see here the definition of an algorithm. So an algorithm is a sequence of unambiguous instructions for solving a particular problem. So therefore, obtaining a required output for any legitimate input in a finite amount of time. So what do you mean of this? So algorithm is nothing but sequence of unambiguous. So unambiguous is nothing but, so there will be a clarity of your statement. So there is no confusion of the instructions we have to give in to solve a particular problem. So for that, for any problem, we are expecting some output. So now we can get that output for a finite time. Okay. So for that, we have to give a finite set of input. So now you can see the representation of an algorithm in a graphical way here. So this is a given problem. So now we have to provide an algorithm, and this algorithm is taken by your computer or your machine, and it expecting some input, and it is going to give some output. So what do you mean by an algorithm? So algorithm is nothing but it will give you step-by-step solution for your problem. So we are following those step-by-step solution and in order to solve a particular problem. So we'll go with, try to understand this algorithm. Let's go with a simple real-time example. Suppose if I want to prepare a coffee or tea. So what algorithm will say, like it will give you a step-by-step how I'm going to prepare a coffee or a tea. So let's start the process. So now what we have to do is, so we have to boil a water. So in a saucepan, we are taken and then we have to boil the water. And later what we have to do, so we have to add a tea or coffee powder to that boiling water. So and after it is get boiled for some time, so now you're going to add sugar to that boiling water. And later you're going to add the milk to the boiling water. And after that, we have to boil this entire combination of mixing of this tea or coffee powder along with sugar and milk. So we have to boil for another 2 to 3 minutes. So now your tea or coffee is ready. So now you have to serve this particular coffee or tea in a cup. So now the process is end. So here in this, so what is your problem? So the problem is to preparing a coffee or tea. So you don't know how to prepare a coffee or tea. So now this algorithm, it helps you step to step how you're going to prepare a coffee or tea. So what this algorithm will say, you can start your procedure and you can take one pan and in that you can pour some water and you have to boil for some time. And later you can add some tea powder or coffee powder to that boiling water. And later you have to add sugar and then followed by milk. And after mixing of all these things, you have to boil for one more 2 to 3 minutes. So then your coffee or tea is ready and you have to serve in a cup. So this is our entire process. So now you can follow this step by step and you can prepare your tea or coffee easily. So now what's the stop will say, like means what is the output here? So the output is nothing but you pour your coffee into some cup, right? So the cup of tea or the cup of coffee, what you are ready to drink. So that is your output. So what is the input here? So the input you are considered here as your pan, water, sugar, tea or coffee powder, or your milk. And all these ingredients, what you are considered, and those will be taken as a input. So now see your algorithm definition, you can understand in a better way. So your algorithm, whatever the steps here you are taking, it is very clear. So there is no ambiguity, there is no confusion. So, right? So that is the unambiguous instruction, right? It is going to solve your problem, right? And what it give you, it will give you some required output in a legitimate time. What do you mean by a legitimate time? You have to prepare tea or a coffee for a 5 minutes or in within of 10 minutes. That is a legitimate time. We cannot do anything for a infinite time. So that it must be in your algorithm, and it will take the finite input, right? And here also we are not mentioned like these many of materials you have to key for the preparing tea or coffee, it will be so on. We cannot provide like that. So input, it must be finite. So we can say like these quantity of these things we have to pour for preparing a tea or coffee. So this is an algorithm. And then now we'll see what are the different characteristics of an algorithm. So now for any algorithm, it needs to satisfy all these characteristics. So what is the characteristics? Input, output, definiteness, finiteness, and efficiency. So now input. So your algorithm is going to take 0 or more quantities or externally it's applied. So for performing a particular task or a particular problem to solve, you have to take sometimes input, and we cannot take even input also. We are getting some solution for some particular kind of problems. And output, at least we are expecting one output. It is going to be produced by your algorithm. So without output, your algorithm is no use. Okay. So means you are doing something, but we are not expecting any output, or we are not getting any output, then that algorithm is not good. And then coming to definiteness. So definiteness is nothing but unambiguous, or it must be clear. Whatever the instructions you have provided in your algorithm, it must be clear, right? And finiteness. If the instruction of your algorithm is traced, then for all the cases, the algorithm must terminate after a finite number of steps. So it must be finite. Like you have to give a 5 steps or 10 steps or 15 steps or 20 steps, whatever it will be. It must be ended at somewhere. It cannot be like infinite way. So that characteristics we can say simply as an finiteness. And coming to an efficiency. So every instruction, it must be very basic and runs in a very short time. So then only we can say your algorithm is an efficient. And whenever your algorithm is going to satisfy all these characters, then we can say that is an efficient algorithm to solve your particular problem. So you can consider any problem. We cannot say we have only one algorithm to solve that problem, right? So you can consider a real-time example. For example, suppose if I want to travel from one place to another place. So I have a different ways to travel from this place to that place. So I have many options. So now if suppose someone will ask me like how I'm going to travel from Vishakhapatnam to Chennai. So that is a problem given for me. So I have a different options, like I can travel through bus, or else I can travel through like a train, or else I can travel through an aeroplane. Like I have many options. So I cannot give a single solution for that a particular problem. So it depends on your constraint. So which algorithm you consider to solve your problem, that is based on the user itself. Okay. So I hope you understand the definition of an algorithm, and then what are different characteristics of algorithm from this lecture. Thank you.